Sometimes you end up designing triple walls, and acoustically, they are not the optimal solution. And here's why. If you got what I mean with a triple wall at first, let's say a double wall, I would say, let's say we'll take a CLT wall here. Then you do a separate frame, air gap, let's say 40 millimeters, and then you put some load carrying wall frame here, a separate wall, and a dual layer of gypsum out here, and of course we get some mineral wool in here. So let's say it's about, what should we call it, 160, 40, 70, and 2 times 13 millimeters. That's the construction here. Not to scale, but you get the point. Now, if we would do the triple wall, that would be like if we do like this. We put a CLT here, and then you have one, maybe we can do them a little bit thinner. They don't have to be that thick, perhaps. One here, and then we do the same thing here. Mineral wool goes in the wall, and this is still CLT. Now, what happens here is when you do a so-called double wall, that is a wall that has a cavity in it, like this, two separate structures with an air gap that you put absorbers in between, inside, like this. Then you will have a resonance frequency in this cavity, and it's kind of like the same principle that when you do the Helmholtz thing with a bottle and you blow in it, and you will get a frequency in return. Or if you have a drum that is tuned to a specific frequency and you hit it, you're gonna sound boom, and then you change the diameter, you take a larger one, it's gonna sound boom. So it's gonna be the same with this one, depending on the size of the cavity, depth, stiffness of it, and a bunch of other parameters. It's like tuning a drum, basically. You will get a resonance frequency in this wall, and if you tap your palm against it, it's gonna sound like boom, boom. If you do it, at least if you do it on this side, it's gonna sound boom, boom, and you'll probably hear it from this side as well, because it's a resonance frequency of the wall, the eigenfrequency. Now, what happens with regards to sound reduction and the resonance? What you'll see, got the frequency here, and we do the difference dNt here, dB. So higher value is better. If you get the double wall resonance, you will probably get some dip, and then it goes up and it's gonna sound better, something like that. And depending on the larger cavity or a smaller cavity, then this bump can move up and down in frequency, for instance. And then the second case, the triple wall. So first we had the, whoa, that's a bit aggressive pen, double wall, and here we have a triple wall. Oops, like so. Okay, so the double wall has this resonance frequency. The triple wall also had the resonance frequency, but the thing is, here we got two of them. And at first, the obvious thing to think when you see this is that, okay, we add another layer here. Of course, we will improve the sound insulation of the wall. Well, yes, that is true. However, not in the low frequencies, because both these cavities, if they are the same size and the same construction, they will also have the same eigenfrequency, the same resonance frequency on both sides. So when you do the palm thing, boom, it's boom, boom, and that energy will go to the other side of the wall and it will easily transmit it and excite this side as well. So you get the boom, boom. It's the same thing. If you have two guitars and you just hit one of them, the other one will start singing with the same notes because they're tuned to the same pitch and everything. Same thing here. And that will result in a principal look of the, if this is the double wall, maybe I should have done them in another color. Let's say double wall is a red curve, and then we do a rainbow curve for the triple wall, like so. Then it's gonna be in principle a bit more like this, a bigger dip, and then it goes up. So it's super effective for high and mid frequencies, very, very good. But that resonance is a big problem, and preferably you want to avoid it. And with the Swedish requirements, we have down to 50 hertz. Most countries, they look from 100. So if you only look from 100 hertz, I don't think you've got much of a problem with this, because those resonances might end up below 100, and then you'll be pretty much fine, at least with regards to the single number quantity of the wall. But well, the physics are the same regardless of what the regulations say, so you will have this extra deterioration of low frequency performance. So if you want to do a wall that is good for low frequencies, you should just maximize the air gap and put as much mass on each side as possible. Avoid the triple layers. But sometimes you have to do triple layers. One example is windows. They usually have 3 glass, and that's to improve the thermal performance of the window. But what you can do is that if you do not use the same cavity on both sides, because then you will have one eigenfrequency on one side. Let's do it extreme. Let's do window. That's actually easier to illustrate. If you got the glasses like this in the window, and this is X and this is X, you get the same resonance frequency. But if you were to do it like this instead, so it's like it's A and B here, and A is not equal to B. Different eigenfrequencies, you won't get that what's it called, when they coincide and amplify each other like they will do here. So then this would be a better option if you really need 3 layers like you do in a window to get the thermal. Okay, that's the principle here. Good to know about, not obvious at all. So in today's video, I just want to show you something that is a bit of a mistake with regards to style. I put a really dark pocket square here. It's dark brown, and you see there's not much contrast here, and I don't think this was actually not a very good look. But if you instead use another color like this, let's do the orange instead. Much better. I like this a lot more. So think about the color matching and the contrasts. If you shouldn't go with the dark on dark. Maybe you can pull it away sometimes. I would not do it with this one. No way. But I really like this green and orange. That's a safe bet. See ya.